So what do you take as u in this problem?
Square root of x plus 1 minus
Yes. Why do you take entire thing? You want to take u as square root of x plus 1 minus 1. Did everybody take that decision? Okay, right. Why do you take that? Because once you do that, y is equal to what? U to the power 3/2. Now we know how to do this. We know how to find du, dy over du. Because we know, what do we know? We know d over dx, x to the power n is equal to n times x to the power n minus 1. We know that. So what we are trying to do is we are trying to use that in here. So we define that u in that way. U is equal to square root of x plus 1 minus 1. So you can write y is equal u to the power 3/2. Right? Now I can find du, dy over dx, which is d over du, q to the power 3/2 times du over dx. Okay, du over dx. See this? This du should always cancel to du. Did you see that pattern? Right? Does that make sense? When you write the chain rule is written as dy over dx is equal to d u over dy over du times, right, du over dx. If you had some other function, maybe p, q, right? You can put p instead of u. Doesn't matter. You can put z instead of u. You can put anything. Okay, u is just a dummy variable. Okay, does that make sense? So now I can write 3/2 u to the power 3/2 minus 1, right, times du over dx is. Now if you want to do that in another way, so what is your du over, you have this function, right, d over dx square root of x plus 1 minus 1. Right? You can take here, you can take v is equal what? X plus 1. You can do that as well. Right? If you take v is equal x plus 1, right? You can write 3 over 2 u to the power, what is this? 1/2, right? D over d d over dv, right? Because I put, let me see, let me put like this, d over dx v to the power half, sorry, v to the power half. Let me write v in this way, otherwise it will be difficult for you. V to the power half minus 1. Right? I'm going to apply chain rule again on this one. So you have 3 over 2, let, right, u to the power half. Now I can apply chain rule on this one, right here. Chain rule here, right? How do I write the chain rule for this one? D over dv v to the power half times dv over dx minus d over dx 1. Right? You can do that. Right? Then you have what? 3 over 2, right? E to the power half, right? And then what is this one? Half times b to the power negative half, right? And dv over dx is what? What is dv over dx? This is v. What is dv over dx? X derivative of x plus 1 is equal to 1. 1, right? Just 1. Minus, what is this derivative of this one? d over dx 1. 1 is constant, so 0. Right? 0. So you have, if I multiply by this one, this is going to be 3/4 u to the power half divided by v to the power half. Huh? What is u? U is the square root of x plus 1 minus 1 to the power half, and then v is x plus 1. Right? Or you can write 3/4 you can do that as well. Yes. Or 3/4. That is this half multiplied by 3 halves. That makes sense? This half multiplied by this 3 halves. So it's going to be 2 times 2 is 4 and then 3. And then there's another way of doing this, right? That's why I picked this problem. Do you remember this one? That was actually in this section. If you have a d over dx g of x to the power n. This is actually a direct consequence of chain rule, right? If you apply chain rule, you can write n times g x to the power n minus 1 times g prime x. Remember that one. That if you remember that one, you don't have to go through the chain rule over and over again. Why is that? Now, if I apply this theorem to this problem, what do? This is actually a direct consequence of chain rule. You can prove that using chain rule. You can prove this by using chain rule. Okay? The proof is given in the book, and I don't want to go through that. So if you do the same problem with that one, what is your g of x? What is your g of x for this problem? Can anybody tell me what your g of x is for this problem? What is your g of x for this problem? The inside thing, right? Because it's something, it should be g of x to the power n. So your g of x, if you assume g of x is equal, it's like you do the u, right? This is. And then you have what? D over dx g of x to the power 3 halves. Then you can write what? According to this equation, 3 halves g of x to the power 3 halves minus 1, right? D over dx g of x. That's the g prime x, right? Then you can find d over dx gx. What is the d over dx gx? So you get 3/2. You can write this one here, gx to the power 3 over minus 1, and d over dx gx is d over dx right. And again, when you see this function, you can put h of x, right? So we have the same thing that we did earlier, g of x, and then you can take this one as h of x, right? The inside. So you have df dx h of x to the power half minus d over dx 1. So what is h of x? You can write h of x. Here h of x is what? X plus 1, right? So you can do the same thing. That's also the same way of solving the by using the chain rule, right? Does that make sense? Right? You can follow any method out of this. Okay. You want to do another one? Let's do another one. Does that make sense? Do you have any questions? Is all good? So let's do this one. Y equals, this is problem number 37, okay? Y equals x plus 1 over x minus 1 to the power 4. So you can use that g of x, or you can use the chain rule. You can put u is equal something and then solve for that. So you can do anything. Okay, take a couple of minutes and try to solve that. Okay. So obviously we want to use the chain rule, right? So what do you define as your u? Or you can define that as g of x. Same thing, okay? So I use u is equal to, what did you use as u? Good. So you can take x plus 1 over x minus 1. That will provide us an opportunity to use d over dx x to the power n, right? So I can write u y is equal to what? U to the power 4, right? Now I'm going to use dy over dx, right? And I'm going to apply chain rule here. Dy over dx, which is equal to dy over du times du over dx, right? So dy over du is easy, 4 times u to the power 3, right? Times d over dx, x plus 1 minus x minus 1. So how do we deal with this one? What is this? It's a quotient. You can use quotient rule, or you can use the combination of product rule and chain rule again. So I'm going to use the quotient rule here. Okay, 4q cube, right? What is the quotient rule? Put the denominator square of the denominator, right? And then get to the numerator. First function to derivate is the numerator, right? So you write the denominator times the derivative of the numerator minus numerator function times the derivative of the denominator. Remember that the derivative of the denominator comes second with the minus sign. Okay. And then this is 4 times u cube. And then you have x minus 1 squared. And this is x minus 1. When you can put the, you can use sum rule, right? And distribute over x plus 1. What do you get? D over dx x plus 1 is equal to what? 1, right? Minus x plus 1 d over dx, it's 1, 2. Very good. So 4u cube x minus 1 squared. This is x minus 1 minus x minus 1, right? So you have positive x and negative x. You can cancel. And you have negative 2. Negative 2 times 4 is negative 8. Right? And then your u is equal to, our u is equal to x plus 1 minus divided by x minus 1. So you have x minus 1 squared at the numerator. Right? And then you get x plus 1 cube, right? And x minus 1 squared, this was there already. And then you get x minus 1 cube again, right? Because that's u cube. U cube is x plus 1 cube divided by x minus 1 cube. It's the same as x plus 1 divided by x minus 1 cube. It's the same as this one. Does that make sense? Right. So what do you have? In the denominator, you have x minus 1, the 5th power, and 8 times x plus 1 cube. So that's our answer. Right? That's how we do this. Is there any problem? Is there any question? Anything that you don't understand? Does that make sense? So the only thing is that now I do feel like that you understand the things that I'm talking in the class, but I want you to go and work out a lot of problems. Then you feel that you face into different problems, you figure out on your own way of doing it, right? That's what you'll be doing. That's what you should be doing. Okay. Now, I would like to work out this one now, number 40. I'm trying to do as many problems as possible, okay? Now I have I went through a lot of rules, so I want to solidify that over and over again, emphasizing that, and then I move forward and do some other concepts, right? And you can probably make a concept map out of all the concepts that we have talked about so far. Try to see whether you can map everything that we talked about so far. Okay, that way, that is a very good way of learning. We talked about different rules and how we're going to use this as a whole, right? And everything is related to each other. Okay, everything is related to each other. The limits are related to differentiation, and differentiation rules and related to limit rules and everything. Okay, it's very beautiful when you figure out that those relations. Y is equal to tangent theta squared minus 4 theta. Okay, let's work this out. Let's work this out. Let's see how we're going to do this. Okay, let's talk about this. So, how do we convert this to a form that we can handle? Jason, how do we form this equation or this function into a form that we can find the derivative by known equations? Take theta out. Is it a, can you identify the composite function inside of that? Yeah, what is the composite function called? Conan. Right. Theta squared minus 4 theta, right? Because it's embedded inside the function of tangent. Right? So if you had tangent x you can find the derivative, right? You know how to do that. What is the derivative of tangent x? Secant squared x. That's straight off, right? You can find that. So if you knew how to convert this into a form of tangent x, then you can do that. That's how you think about this problem. I want you to learn how to think about this problem, right? You wanted to convert this into a form that you already know, so that you can find the derivative of that. So what is the easiest way to convert it to tangent of something? Taking this as a some function, right? So I call this u is equal to theta squared minus 4 theta. So identifying that is key, right? Y equals now tangent u, right? Now y is equal to tangent u. Can you do now? Tangent u. So you can find dy over dx, which is, sorry, d theta, I'm sorry, d theta in this case, d theta, right? dy, right, over du times du over d theta, right? So what is dy over du? This is d over du tangent u times d over d theta, theta squared minus 4 theta, right? So what is this one? Secant squared u, right? If you derivate this one, theta squared d over d theta, theta squared minus 4 times d over d theta, theta, right? Secant squared theta squared minus 4 theta. Now I can substitute because I have finished the derivation, differentiation, and I get that d 2 times theta, right? 2 times theta minus 4. And I can take 2 as a common factor, secant squared theta squared minus 4 theta times theta minus 2. Okay. The secant is only applied on this part, right? So you can take this one out. 2 so this is the answer. So the key is to identify that. Key is to identify that. Okay, let's go to a little bit challenging problem. Let's go to this one. 55. 55 is y equals cosine 6x plus sine squared x power half. Now there are a lot of embedded functions in here. I want you to take it as a piecemeal format, right? Piece by piece. Don't be afraid by seeing the expression. Try to convert into a normal form so that you can find something out of it. Then go from there.
for that part. If you hold it this part, you can take care of that part, right? Think about how you do this. Think about how you formulate these two parts, right? You can probably use, well, some, right? Then you get two derivatives. Think about those two derivatives. Okay? As I think, we can take piece by piece. Okay? Well, never ever like that. So, one of the things that I want to mention, do not write.
This is completely different notation. Then, so if you write like this, something like this, d over, let's say you have a long expression, right? D over this expression's cosine 6x sine squared x or something like that, and then put dx like that. Don't do that. Right? You should write, because this is a operation. D over dx is an operation. This is not something that you can cancel to something. Okay? D over dx is the operator. So keep that just like this, always. They go together, okay?
Don't try to do it in one shot. Once you develop more skills, you should be able to do it. You figure out.
Right. I saw that all of you, most of you, have figured the first step correctly. That is, you got u equals cosine 6x plus sine squared x, right? Now that's a very good point, right? Once you got that one, you have y equals u to the power half. Now you can handle this, right? Now you can handle this. Now your dy over dx is equal to dy over du times du over dx. Right? So the first part is correct. So you have dy over du is d over du, u to the power half, times d over dx. Now we have a expression of two functions, 6x, cosine 6x plus sine squared x. Okay, always trust on your basics, always, right? Now, what the basics is, now you can do this one easily because you know d over dx, x to the power n is equal to n times x to the power n minus 1. Right? So you can do half times u to the power negative half, right? Half minus 1 is negative half. Are you all with me? Okay. Now, how do I do this one? This is where most of you struggle. Now, what I would do is, I would use the sum rule first, because obviously I need to differentiate two functions here, two parts, right? Okay. So what I would do is, I would take d over dx cosine 6x plus d over dx sine squared x, right? Now, those two are what? Trigonometric functions, right? Now, what do we know about derivatives of trigonometric functions? We have learned these, right? We have learned d over dx. This is beautiful. D over dx sine x is equal to cosine x. Remember? Right? And we also know that d over dx cosine x is equal to negative sine x. Right? Now, do we know d over dx cosine 6 of x? No, but we can convert that into cosine x. How do we convert that into cosine, a form of cosine x? Just like we converted this into u half, right? How do I convert this into this format? What do we do? How do I convert cosine 6 of x, something cosine v, or cosine t, or cosine theta? How do we do that? Is it a composite function? Cosine of x we know, but we don't know cosine of 6x. How do you do that? I know you know that. So what did you do? Okay, come on, we did this one. What did you do there? You told me the answer. This is one of you told me the answer, right? What did you do? We wanted to have a tangent of something, right? Tangent of u. So we took theta squared minus 4 as u. Now we have cosine of 6x. Then 6x to what? Some other variable. Let's take, that's good. Let's take, does that make sense? It's so easy. Let's take v as 6x. Right? So you have, then you have half e to the power half d over dx cosine, right? V, right? So I can write what? D over dv cosine v times dv over dx. Chain rule again. Does that make sense? Right? Plus, this is sine squared x. Remember that one? What is that? d over dx gx to the power n is equal to n minus gx to the power n minus 1 times g prime x. Remember that one? So what is this one? This is sine x to the power 2. Sine x of square. So what is g of x here? What is g of x in this case? Can you relate this into this one? I'm asking, what do you take as g of x to form this quantity into this? Do you understand my language? Huh? So what is sine squared x? Let's get that one first, straight first. What is sine squared x? Is that equal to sine x squared? Is this equal? What is this one? Sine x times sine x. This is not equal, okay? Sine x, big no. Okay. Sine x times sine x is what? Sine x squared. Sometimes we write it as, most of the time, sine squared x. So what is this? This is g of x times n. Oh, yeah. My bad. I am wrong. Yes, that's good that you pointed out. I have written this completely wrong. So let me change it. This in the book. But let's work out of that way. Otherwise it's a long way. So let's do this problem, and then we can do the other one. No problem. Let's do this one. So you have sine squared x here, right? If I take my g of x as sine x, this is g of x squared, right? Let's take g of x is equal to sine x. Is that complicated? Now what do you have? D over dx g of x to the power square. Does that make sense? Or I can take it as just p or something like that. Sine x equal to p. So that's p square. Again, chain rule. All right. Again, chain rule. So you have what is d over dv cosine v? What is d over dv cosine v? What is that? It's in here. Negative sine v. And what is dv over dx? What is v? V is 6x, and then dv over dx is 6. Good. Times 6 plus, what is this one? N is 2, right? G of x is sine x, right? Sine x. So you can write just g of x. I'm going to substitute that later. 2 times g of x to the power 2 minus 1. What is d over dx g of x? D over ds d of x is cosine x, right? So I can write this is half u to the power half negative 6 sine v is what? What is our v? 6x, right? I'm going to substitute x in terms of x now, right? Plus 2 times g of x. G of x is what? Sine x, right? This is d over dx. Sine x is what? Cosine x. Does that make sense? Does that make sense? Now in trigonometry, you might have learned that 2 times sine x plus times 2 times sine x cosine x is what? Sine 2x. I don't know whether you remember, but even though you don't remember, that's fine. You have done the differentiation. So you have half, u is what? Cosine 6x plus sine squared x to the half, and then you have 2 times sine x cosine x minus 6 times sine 6x. That's your derivative. Okay. So if you consider that this is g of x, 6 of x cosine 6 of x sine squared x, you can write half times 1 minus half minus 1, and then the derivative of the other one. Right? You can use this one a couple of times for this problem. Now actual 55. So does that make sense? Does this problem make sense? What we did? Okay, so this is not 55. It's a modified version of 55, but I can do the 55 as well. This is the same thing. Just a little bit of work. Okay, so that's how we do this. Does that make sense? So my suggestion is to work as many problems as possible and then come up with your questions. And then we can discuss with those things in class. I'm going to assign some problems as well. But it is good to work on these things on your own. Right? There are a lot of problems in this book. Okay. So that's about that discussion. And do you have any questions based on that? Are we all good? Okay. Let's take another 5-minute break. Let's reconvene again at 8. And then go from there.